All right, good morning, class. I hope that you are all fine and you have completed your lab 1 with all the tasks. And today we are going to perform the lab 2, in which we need to trace the response of non-inverting amplifier using the LM741 in LTSPICE. Previously, we performed the amplification process by using the NPN transistor, and it was the conventional and internal circuit of the you can say that the generic form of IC, the circuit that lies inside the IC. So today what we are going to do, we are going to perform all the steps that we have performed in lab 1 using the built-in IC, that is LM741. And in LTSPICE we do have the generic form of universal operational amplifier, which can be modified as the inverting as well as the non-inverting amplification process. So there are very few things that require in today's experiment. The very basic one will be the feed forward resistor, other one will be the input resistor, and the universal op amp IC. Okay, this is a very basic structure of the 741 operational amplifier IC. It has 8 terminals, and there are 2 inputs. One will be served as the inverting and other one will be the non-inverting input, and there is only one output at pin number 6. There are 2 biasing power supplying pins. One is the pin number 7 that consists of the positive biasing, and the other one is the pin number 4, which is the negative biasing. Okay, if you want to perform the offset, if you want to give the offset in your input as well, so you can use the offset pin number 5 and offset pin number 1 for your 2 input pins, that is the 2 and pin number 3. Okay, this one pin number 8 is normally not used. So let's start our this whole schematic diagram, and we will use it using the LTSPICE simulation program. Okay, now before moving toward this simulation, I would like to share the few applications of this 741 IC, that is the comparator and inverting amplifier such as the summing amplifier, and the third one is the non-inverting amplifier such as the voltage follower circuit, differential amplifier, or you can also call it as the difference amplifier. Okay, the differentiator or as an integrator. The sixth one is the filter, and the seventh one is the peak detector, and eighth one is the analog to digital converter, also known as the A to D, and the last one is the oscillator. Okay, now this IC is also used as a basic part of performing all the mathematical operations as been stated over here as a comparator, summing, and the subtraction program, and this structure is being used as a basic part in your computer chips as well. So let's move ahead. Now in today's lab we are only concerned about the non-inverting phase of this operational amplification process. So for non-inversion process, the equation that is being used is the V output, that is equal to 1 plus RF over R input and multiplied by the input voltage. Now this structure is very much similar to that of the voltage divider rule, but the only difference is that it's serving as the non-inversion process and non-inversion phases. So we have just added the 1 plus RF over R in multiplied by that of the input voltage. In order to complete your lab, you need to read all the procedures step by step, and you need to calculate the desired outputs that are being mentioned in the form of the fill in the blanks, and some of them are being asked to you in the form of the table. Now in this lab I will just demonstrate you how you are going to perform the analysis. The rest is your work to read the procedure and submit the assignment using the teams. So let's now finally move toward the LTSPICE software. Okay, now I do hope that you are all aware of finding the components using the edit prompt, and there are all the kinds of the required components such as the resistor, capacitor, inductor, diode, and the component box, which comprises of all the kind of the voltage sources, etc., as per your requirement. So I have just fetched my required operation amplifier IC as by universal op amp, and it has all the required features as concerned with the today's lab. So what you need to do, you just have to place it over here, and you need some required feedback resistor and the input resistor as R1 and R2, and you need to prepare the circuit as I have prepared in this LTSPICE. So now you can see that this is the input voltage. It is being connected with the positive terminal of this operational amplifier, which means that this process will be non-inverted operation amplifier, and also means that whatever the input, if it is positive, the output will be amplified but will also be in the positive region. Now if I were using the inverted operation amplifier, so in that case I must have connected my input voltage with the negative terminal of this universal operation amplifier, and whatever my input voltage was, it will be turned into a negative. For example, if this is a DC, I have given the positive DC, the output will be positive because of this non-inversion. If it is about to be inverted, then the output will be in the negative region. Similarly, if I have given this sinusoidal or AC voltage, the output will be 180 degree out of phase. So I do hope that you are aware from all these theoretical point of views. So let's move ahead. Okay, now if I use the equation number 3, now I need to calculate the output gain. What should be my output gain? By definition, the output gain is the output voltage divided by the input voltage. Now if I drag this input voltage to the denominator of the left hand side, that is V out over V in, that will be equal to 1 plus RF over R in, which is the gain of my operational amplifier. So if you look it into the circuit, the feedback resistor is 10 kilo ohm and the input resistance is 1 kilo ohm. Now if I substitute these values in this equation number 3, now what will be my gain? The 1 plus 10k divided by the 1k, this will become the 11 units, which will be the output gain of my operational amplifier. Okay, now for instance, if I have given the 1 volt DC input and my gain is 11, my expected theoretical output voltage would be 11 volts. Okay, is that, if it is true, my practical simulation result should also match with this equation number 3 values that I have substituted in this. Now let's see. Okay, now I have made the connections. This is my positive biasing and this is my negative biasing as according to the circuit that is being presented in this figure. One is pin number 7 positive biasing and the pin number 4 negative biasing. I have connected them easily by the positive voltage 15 and the negative biasing as the 0 volt as a reference. And in a step ahead, I will also tell you what is the importance of biasing. Now you need to remind yourself the basic structure of the amplification circuit from the lab number 1, where I was using the DC biasing divider voltage biasing, so that was biasing the collector side of the NPN transistor. So I was also biasing the collector with the 20 volt in that circuit. Now in this circuit I am just giving the 15 volt for the biasing. Okay, now this is the same. If you remember that circuit, that circuit is being placed inside this amplifier U1. Okay, so one is there are two ports that are being for the input, where you can connect the resistor, the input resistor, or the AC voltage or the DC voltage if you want to amplify it, and this is the output terminal that was that is similar to that of the output, that is being coupled with the C2 capacitor, and all that capacitance and the resistance are being fixed in this U1 black box. Alright, just we are now simulation is about to run. We can check whether we have entered all the required information. This is a transient, it's about 0.5 second, and just press OK. It's all looking fine, and this is the point trans 0.5 second, and just press the run button. And this one is the input voltage, that is 1 volt, and according to our calculation the gain of the circuit is 11 and the input voltage 1, so our output should be 11 volts. So you can easily visualize that this is the output at the node VN001, which is 11 volt. So that means that our theoretical result is fine, and this one is the input voltage, which is at the node VN004, it's 1 volt. So I think that our amplification is now in the good position. So okay, now let us check the role of this biasing. As you can see that the gain of this U1 is 11, and we have 1 volt input, and if I give now the input to be 2 volt, and the gain of the circuit is 11, so the output expectedly must be 22 volt. Fine, so let's change it to 2 volt and run the circuit once again. This one is the input, which is 2 volt. Fine, the output is approximately 15 volts. However, by our calculation it should be 22 volts. So what went actually wrong? Now here comes the role of the biasing circuit. Now if you remember the lab 1, the basic circuit diagram, this one is the basic circuit diagram. Now this one is a biasing, 15 volts you are biasing positively over here. So whatever the input was, it was lying under the rating of this DC biasing, that was easily amplifiable. Now if I'm giving the voltage that is going to exceed the limit of this biasing circuit, will enter the saturation point. That means your output voltage, if it crosses the over limit of that biasing value, it will enter the saturation region. Now in saturation region your signal gets lost, nothing is being transmitted over that point. So what you need to do, if you extend the limit of this biasing, most probable chance is that your signal will be transmitted according to your calculation to the output. Now let's change our circuit according to the requirement, and let's check whether we are able to receive the amplified version or not. Okay, now I'm changing the 15 volt to 30 volt, and the input is 2, and we know that output should be 22 volt. This one is the input and this one is the output. So you can see that the output is exactly 22 volt because it is lying under the rating of your biasing value. So we are now clear that what is the importance of biasing. Now similarly, what you need to do, you need to change this DC input with the AC signal according to your required frequency, whatever you think, okay, and fix the amplitude as well. One must be the positive as well as the negative cycle as well, and you need to rerun the circuit. Now if you get your amplification according to your requirement, that is fine, and if you see that the positive cycle is under the limit of this positive biasing circuit and it is being amplified, so okay, fine. Now if you see any kind of clipping that is being occurring in the negative cycle of your AC input voltage, you need to change the limit of this 0 as well. And when you do, just record the answer, attach the simulation picture or the simulation file in your lab manual and forward it to me using the Teams. So for one example, I can share this thing as well with you as just one example for your understanding point of view. Alright, I just have entered the values of the sine wave, which is the AC signal, 2 volt amplitude and the maximum 2 volt input signal with 50 Hertz frequency, and let's check it out. The conditions at this point are same as well. Let's see what happens at the amplification. Okay, this is my input, 2 volt positive side and 2 volt negative side, and the amplification should be in the same manner as we did for the DC signal as well. Now let's see. So you can see that the positive cycle is being amplified with the same gain value, which is 11 is the gain of the system and 2 was the input voltage, so 22 volt is the output for the positive cycle. And if you visualize this thing, that whatever the negative cycle is, it's been clipped, that no data is being fetched from this side. That means whatever the biasing you are giving on the positive side, it must also be on the either side as well. So what you can do, you should increase the limit, that is minus 30 volts, and cross the screen as well and rerun the circuit. This one is the input, this one is the output. Now that is perfectly fine. The positive cycle is being amplified with the same manner as the negative cycle. So I do hope that you are now fully understand the importance of the biasing, the positive and the negative biasing for the operational amplifier 741 IC, and you can perform the lab with all the procedures being asked and the tables that are being required in this lab. So I do hope if you have any kind of question, just do comment or feel free to ask. So thank you very much.